Okay, so this time we're going to do multiple regression and focus on identifying influential scores. Follows straight on from the last one. Okay, so we're going to see how to run the multiple regression, get the scores that measure influence, assess whether a score might be influential, and evaluate both the behavior of the individuals, and then have a look and see whether they're actually having any influence or not. Okay, so again, just to remind you of the research question: do spelling, reading, engagement, and cognitive skills predict literacy skills in primary school kids? And of these variables, which are the strongest predictors? Okay, to do that, we're doing a standard multiple regression. If you're evaluating influence in something more complicated, like a hierarchical multiple regression, pretty much if somebody's having influence, they're going to have influence over the whole thing. So just a standard multiple regression will identify who's having influence. And given the last step of the hierarchical is the same as a standard multiple regression, you should be able to find out who's influential just using a standard multiple regression. If you've got something, at one particular step that isn't quite what you expected, and the p-value maybe is, touch and go, you could maybe see, okay, can I look at influence over particular steps? Usually it's more work than it's worth. By and large, just do a standard and you'll find anybody who's having influence. This particular research question is just a standard anyway, so we're good to go. Okay, so let's bring SPSS on board and play our game. Okay, so the first thing we're going to do is run the multiple regression. Okay, so there we go, regression linear. And I've still got it all set up from last time, but one thing I've added, I put the subject number in where it says case labels. If I want to identify particular individuals in a residual plot, that can be handy if they're labeled by their subject number, rather than just the row that they happen to be on in SPSS. Especially if I go and start sorting ascending or descending by things like Multiple distance, they change the row that they're on. So I want something that I can say, you're not just on that row, you're that person. So the subject number as the case label can come in handy. I'll show you what that does later. So we've got all our stuff set up there as it should be. Our plots are still requested, so that's all good. And the thing we're going to add in order to get the scores we need to get for determining influence, we're going to get Multiple distance and Cook's distance. Some people get leverage values, but it's virtually, it identifies anybody that Multiple distance would have anyway. They're so similar in the function that they serve. And we can get studentized residuals, which again, because everything's based on a sample, you'd rather use studentized than standardized. But they're pretty interchangeable, they don't make a lot of difference. Sometimes you can use DF beta to find influential scores on a particular IV. That's discussed in the book, we're not going to worry about it, but it's in there if you want it. Okay, so we say okay to that, and that's everything we need there. So fire in a hole, we run our multiple regression. So there we go. There's our results, same as always. So not a bad thing to just have a look at the results. I've got 53.9% of the variance explained. That's my R squared value. And if I look at my beta values, I've got a significant contribution from spelling and reading and cognitive skills, but not from engagement. Okay, it's worth noting because we're going to look at whether people change that pattern, so it's good to know what the pattern is. Okay, so what we want to do now is go back and have a look at those scores that we saved, and we're going to see if we can find people who are potentially influential. So if we go back to our data set, here we have studentized residuals, Multiple distance, and Cook's distance. All handy. Okay, so I don't know why, I always start with Multiple distance. I think I've tended to find that it is the most effective at finding people, but that's going to depend on all sorts of things. So, but it's where I start. So I'm going to go sort descending from Mahalanobis distance, and okay, I've got a 50 and a 33 and then a 13. I'm going to need to find out what cutoff I'm using. So I've prepared that earlier on a slide here. So Mahalanobis distance is assessed against a chi-square distribution. You're looking for critical values of chi-square that put 0.001 of the distribution in the tail, which is 0.1%. Okay, because you don't want to find a lot, you just want to find the most influential. And I looked it up in the book ahead of time for 4 IVs, which is what we've got. Critical value is 18.48467. Page 134 of the book. Studentized residuals, because we've got a large sample, we're going to use plus or minus 3.3 to evaluate that. Smaller sample, you might back it off down to 2.58, something like that. Again, that's covered in the book. Cook's distance, you'll read in all the books, greater than 1 is influential. I don't know if I've ever seen a Cook's distance greater than 1. Then there's that formula 4 divided by n minus k minus 1, which is a bit too fussy. It'll find you too many people. So tend not to use that. Might work for a small sample, but for a large sample you'll just be chasing your tail trying to find, is this person influential? So a situation like the one we're in, reasonable size sample, we're going to look for a gap. Okay, if you've got some that are over the cutoff of 4 divided by n minus k minus 1 and there's no obvious gap, pick the top few and have a look at them. And if the top few aren't having any influence, chances are nobody will. Just don't be chasing too many individuals. You're just looking for the most influential. Plenty more on that in the book, and it was covered in the lectures early on, so you should be good to go with that. So now it's time to go back to SPSS. Okay, so here we are with SPSS back up, and we've got these top 2 that are above our cutoff of 18 point whatever it was. Okay, so those top 2 have been identified using Mahalanobis distance, and that's person 172 and 125. If you go back to the material that we used in the workshop, you'll see all the notes on all this. I'm going to be referring to some of that in a second. We also then want to have a look at studentized residuals. So here we're going to sort, doesn't matter which way you start, we'll go descending first. So we said our cutoff was going to be 3.3. Our highest one on the positive side is 2.7, so miles away. If I was using 2.58 for a smaller sample, I might be having a look at a couple of those, but really, chances are they're not having much influence. I'm also going to have a look at the other end by sort ascending. There we go. Minus 2 is my lowest one, so again, miles from 3.3, nobody that's likely to be doing anything there. Okay, so then I'm going to go to Cook's distance and sort that descending. Okay, so the highest value is 0.226, well short of 1, but a fair gap between that person and the next person. Person after that's not too far away, a little bit of a gap there, but not so much. And after that, they're just drifting down, no more gaps. Okay, so really we definitely want to have a look at that person. What do you know? It's 172, highest Mahalanobis distance. So, we could probably make a case for having a look at both of those. Let's start with that person. If they're not that strange, then chances are that person's not. Cook's distance is a measure of influence. So, if that person's not making any difference, then very unlikely that person is. So, as we did in the workshop, just to keep it to a manageable number, we're going to look at 172 and 125 that we found by Mahalanobis distance, and we'll throw in 117 because they've got a decent chunk of Cook's distance. If I was energetic, I might do that as well. but it's not in your notes, so I'm not going to. Okay, so it's those three people, 172, 125, 117. Okay, but while we're here, the other thing that we want to look at is their behaviour. Okay, so we look here at, we're not interested in their competency, but we want to look at engagement and the other scores. So we put all these scores into the table back in the workshop, and if you remember, we found that this person was really low on engagement. Just as a reminder, there's the table we did in the workshop. Okay, so this person 172, so I've got all their scores in there. They are above the mean on the DV, above the mean on spelling, above the mean on reading, rock bottom on engagement, and then back above the mean on cognitive skills. So this kid is bright, all the skills going on, but totally disengaged. I don't know, bright but bored. You know, the teacher probably knows this child and would give you some insight, but just looking at the numbers, that's all we can tell. There's 6 standard deviations below the mean on engagement, so they're truly unusual. Looking at the behaviour of 125, 1.5 standard deviations below the mean on the DV, so you expect them to be below the mean on all the other measures. They are on all except reading, and they're particularly low on cognitive skills, score of 21, which is, you know, getting on, you know, 2.5, 3 standard deviations below the mean. So they're below the mean on the DV, below the mean on the IVs, extremely below the mean on cognitive skills. Reading's a bit odd. You know, they're probably an extreme example, except for that reading score. So they're a bit strange, worth having a look at. Score 117, bit above average on the DV. So what are they, 726 versus 713. So they're 10 above the mean, standard deviation 60. So they're, you know, a sixth of the standard deviation. So they're very average, but just, you know, fractionally above, and a bit above the mean. Where are we? Actually, no, they're below the mean on the others. 89 on spelling, 90 on reading, 2.7 on engagement, 20 on cognitive skills. Okay, so they're close to average on the DV and fairly consistently below average on the other things. So they're a little bit odd. Okay, yeah, they probably should be below the mean, but they're almost at the mean. They're not that strange on the DV. So, you know, they're a little bit different, but not radically so. Okay, and remember that was the highest Cook's, second highest Cook's distance after 172. Still not that unusual. Okay, let's go back to SPSS and see what happens when we rerun the analysis with those individuals taken out. Okay, so we're going to rerun the analysis now, except first I have to get my filter variable happening. You'll see I've got the filter variable there, but it's not active. This person is a 0, which if I turn on the labels, says not selected, but you'll notice over here there's no diagonal line. So my filter's not working at the moment. Okay, so I'll turn that back off again. So I need to get it working. I go to select cases, which you can see there. And instead of the original thing where I set it up initially to say subject number greater than 0 or any condition that I know everybody in the dataset satisfies, that was how I set it up in the first place. So I'll just show you what that looks like in case you've forgotten. So subject number greater than 0. I have already double checked to make sure every participant has a subject number greater than 0, so I know that gets everybody. If I click that, I will get a new filter variable. It'll actually replace the old one and it will be active. But instead of doing that, I'm going to come down here and say use filter variable, grab my filter. You can see their subject greater than 0 is still in the label for that variable, reminding me how I set the filter in the first place. Put that across there. It's always got filter in the name. It has this filter $ thing. If I click OK now, that will reactivate that filter. So I'm going to do that. So now if I go back and look at the data set, my filter is now active. See the diagonal line through row 1. So that says person 172 will not be included in the next analysis I run, and that suits me just fine. So I'm going to go to my recently used dialogues button, go back to linear regression. Before I run it, I don't need to save fresh sets of those, so I turn those off. Everything else I can leave alone. I'm going to click OK. So first thing I'm going to do is let myself know what happened there. That was 172 out in this set of results. Okay, and I'm going to, you'll notice I'm using this navigation pane over here on the left. It's much easier at this point. So first thing I want to do is see the model summary. That's going to tell me about R squared. My model summary now says 0.544. Do you remember what it said before? It said 0.539. If I click back, and here's where it's nice, if I use this navigation pane, all the other junk stays the same, but the numbers change. 0.539. See that there? Versus 0.544. That's not a big deal. Okay, 53.9, 54.4. It's a sampling error. It's nothing. It's the kind of change I would get if I took another sample, which is what I say. It's similar to sampling error. So that's no big deal. But R squared change is not the only thing I have a look at. I want to look at the coefficients table down there. Now I'll navigate back to the first lot up the top. So those coefficients are there. Remember, engagement was non-significant. If I now click on the new ones, again, everything else stays the same, but the numbers change. Okay, you can just click back and forth to see what's different. Spelling was initially 0.385. It is now 0.347. Looking at the beta values. P-value was less than 0.001 and still is. No change. That's of no consequence. Originally, reading was 0.236. It is now 0.250. Again, big deal. No difference. It was significant. It still is. No big deal. Engagement was 0.105 and non-significant. Engagement now is 0.145 and it is now significant. 0.105 to 0.145 is, it's gotten half as big again. But the important thing is that it's now significant. That changes the story. That's important. That matters. That's influence. So I go back there. Now I'll have a look at cognitive skills. Was 0.163 and it is now with 172 out 0.161. Again, that's nothing. 0.163, 0.161. No meaningful change. But it did change engagement. Okay, 172 is having influence. Not unexpected that it would be on engagement, because that's where they were unusual. Okay, so 172, definitely unusual. To evaluate the other ones, I'm going to put 172 back in. And now I'm going to evaluate 117, exactly the same way. So linear regression, run that. My saved things are turned off. Right there on the title, I'm going to say 117 out. Okay, model summary 55.2, and I go back to the original set of results. Okay, because I want a set of results where the only thing that was different was whether this particular participant was in or out. So I go back to those original results. So go back up there to the model summary, was 53.9, is now 55.2. It's gone up a little, but nothing to write home about. Okay, it's 1 and a bit %. Nothing of any consequence. Again, I'll have a look at the coefficients as well. There they are in the original set, and here they are with 117 out. So my coefficient for spelling was 0.385, is now 0.372. Was significant, is significant, no big deal. For reading was 0.236, is now 0.237. Yeah, that's nothing. Engagement was 0.105, non-significant. Now it's 0.107, still not significant, no change. Cognitive skills was 0.163, is now 0.190, but it was significant, it is significant. You know, changed by 0.03. It's not that big a deal, so I wouldn't call that influence. So 117 isn't making any difference. Next one to evaluate is 125, and if I click on the row number, they get highlighted right across. So I go there and click 0. So just to make sure I'm not taking the wrong person out. Yep, the diagonal line is against 125. We're all good. 117's back in. So we just rerun the analysis again. Click OK. Title. This is 125. Out. Okay. This time the model summary says 0.536 was originally 0.539. And there is no change there. Okay, coefficients for 125, 0.398 significant, 0.212 significant, 0.109 non-significant, close but not quite, and then 0.168 significant. I'm starting to know these numbers, those aren't different. Have a look at how they change. There you go. Not meaningfully changed. So 125 doesn't make any difference either. Okay. Now I did mention before that I was going to show you the adding the case labels function, put the subject number on case labels. You'll see there on the normal probability plot and on the residual plot it's put everybody's subject number against their dot, okay, which makes it a little bit messy. Can help you find people. Okay, so my highest studentized residuals person number 18, but they were below 3, so they're no big deal. I've got 84 down there. There's 125. But see, 84 was not more influential. So you can't really use residual plots most of the time to find people. Sometimes the strange people will stand out, sometimes they don't. If you look at that, 172 is hiding. You can't, like, where are they? I can't see them. Okay, they're in there somewhere. So they're not standing out. Sometimes they will, and having their number against their dot comes in handy. Another thing you can do is you can open that up and you can do this. I can hide the data labels so the numbers all go away. Then I can use this symbol here, which is, you know, it's got like a crosshairs, it's a target thing. I have been known to refer to it as the Who Dat button, because it allows me to point at a person and say, Who Dat? That's person number 84. Lame, I know. Bear with me. I'm the right age to make dad jokes, so, you know. So there you go, you can find individuals that might be of interest. Okay. So there was 117 that was interesting, 125 was there, but they don't stand out more than some of these others. So you can't always use residual plot to find the influential scores. Sometimes you can. And if somebody's standing out and you're curious to know who they are, that's one way of finding out who they are. Okay. So we decided that 172 should come out because they change the results of the regression. Okay. I think I've got a summary of all this in here. Okay. So we decided 3 participants were potentially influential, 172, 1 17 and 125, only one was actually influential. So only one of them would be removed. We would report the results with 172 removed from the analysis, and we'd say so. The influence wasn't on R-squared, because that didn't change. The influence was on contribution of engagement. Okay, this kid was low in engagement, high on everything else, which was unusual compared to everybody else. And with them removed, engagement becomes a significant positive predictor of literacy skills. This child on their own was making it non-significant. For everybody else, high engagement means high literacy. For this kid, he had high literacy, but he had really low engagement, so he's very different. So he's not representative of the population, and the results with him removed are more likely to reflect your average kid in a classroom, what's going on in your average classroom. It's more likely to generalize to the population. It's more likely to be reproduced in another study if you ran it, which is to say that with 172 out, the results are more reliable, and more reliable means more valid. So you're better to report the results with 172 taken out. But you only take people out because you've got a really good reason to do it. If you do it just because it suits you, you're overfitting your data and you're playing games with the analysis, and that's called bad statistics. Okay, so that's how to identify influential scores, evaluate them, remove them, and get more reliable results.